Hey everyone, it's Mr. Canfield. Today we're going to be in 6.2 with this activity, Supersize Me. So last lesson we compared LeBron's photo to real life LeBron and resized his photo to notice relationships in the dimensions. Today we'll look at dilations more closely on a coordinate grid. Okay, so his triangle ABC was dilated to produce its image A prime, B prime, C prime. We read those as prime, those little apostrophes. So that is read as A prime. How can you tell this is a dilation rather than a rotation, translation, or reflection? Okay, rotation, it rotates. Does this look rotated? No. Well, okay, good. Translation is literally just a move. Move with no resize. So that'd be, if it moved from here to here and it stayed the same size, well, that B to C and then B prime, C prime, so BC and B prime, B prime, C prime are clearly not the same size. So I can see that. And then reflection, this is like a mirror. I tried to write mirror backwards, my hand failed. But you know what a mirror does. Oh boy. Okay, so it's pretty clearly not any of those, but how do we know it's a dilation? Well, dilations, the first thing they do is they follow a scale factor. So, oh my goodness, excuse me. I'm filming this right after daylight savings time got reversed and it's an hour earlier. Okay, so if we look at BC and then B prime, C prime, we can see this is 1, 2 spaces, and this is 1, 2, 3, 4 spaces. So if I can show that all the sides are double what they used to be, then that's a dilation. Or it's, they're scaled up appropriately. And the way we do a dilation on paper is we pick a point that we're going to dilate about. And so in this one, these are dilated about the point P. And if you start at P and you draw a straight line through, you can see that that straight line goes through each point of both shapes. It goes through the same spot of both shapes. And so any other place that we wanted to do a dilation, we could calculate and find spaces and then do another one. We could even go and do it half. And then if we look, this line here and this line here are parallel, which we can mark with these little arrows, right? And say these are parallel lines. We can say these right here are parallel lines. I hope that one's obvious. And then these here also look parallel. Now I say look parallel. We are going to confirm that in just a moment. But that's how we can say this is a dilation. Okay. So which of the 4 points is the center of? I spoiled it. Oops. All right. Find the following lengths. All right, let's start with the easy ones, right? BC is 2, right? And then B prime, C prime is 4. So that would mean that our scale factor, we double this to get to that, right? So that's all well and good, but now we need to figure out the rest of these lengths. And so we're gonna use Pythagorean theorem for all of these. I've already pretty heavily marked up my diagram. Let me grab another copy. So if I'm trying to find AB, well, what you can do is you can draw a little right triangle in here What's this side? 3. What's this side? 1, 2, 3, 4. So 3 and 4. So to find AB, I'll do 3 squared plus 4 squared, and then we'll take the square root of it, because these are both legs of our right triangle, and that's our hypotenuse. So if I do that, 3 squared plus 4 squared, that's 9 plus 16, that's 25, that's square root of that's 5. So AB is 5. So if this is a true dilation, if they're truly similar, then we would expect that to be double that. We'd expect this to be 10. So let's see if it works. A prime, B prime. Well, here on A prime, B prime, here's our triangle. Looks like the bottom is 1, 2, 3, 4, 5, 6. 6 squared plus, and then the height is 1, 2, 3, 4, 5, 6, 7, 8. So 6 squared plus 8 squared, that's 36 plus 64. That's 100. What's the square root of 100? 10. 5 doubles to 10. Cool. Now let's find our next one. AC. AC's up here. So we got a 1 and we got a 1, 2, 3, 4. So 1 squared, oh, I'm off screen. 1 squared plus 4 squared. That's 1 plus 16, so that's 17. So square root is 17, which is about 4.123. I'll leave it there. You can write 4.1. So my guess is that this is going to be 8.246. So let's calculate that. So this time it goes 2 here, and then 1, 2, 3, 4, 5, 6, 7, 8. So 2 squared plus 8 squared, those are our 2 legs. That's 4 plus 64, that's the square root of 68, because we're going to take the square root of it in the end. And square root of 68 is, lo and behold, the exact number that we just came up with. So any of these times 2 gets us the new stuff. How many times bigger is the image than the pre-image? So image is the new, pre-image is the old. So 2, scale factor. Let's see if there's anything I need to add there. Consistent scale factor. Find the slope of AB and the slope of A prime, B prime. Now, since we are talking about similar figures, that means that these slopes should be the same, because slope and angle are very closely related. So let's see. If I'm trying to find the slope of AB, let's pretend for a minute that you and slope don't get along. Let's say you're struggling with it. That's kind of where I'm starting from. So let's see. So if I'm going from A to B, I think I might need a third copy of this. From A to B, I think color helps here. So the easiest way to calculate slope when we have a picture is we count how many spaces it rises and then how many spaces it runs. That is the classic phrase. So I'll start at, it doesn't matter which one you start at. If I want to start at A, I can start at A. If I want to start at B, I can start at B. If I start at A, I'll rise 1, 2, 3, 4 spaces, and then I run 1, 2, 3 spaces, but I ran to the left. You want to remember, up is positive and right is positive. Left is negative and down is negative, and those signs matter. We just carry them with us. So I went up +4, I went left -3. And so my slope of AB is rise of 4, run of 3, and I had a single negative. So I could say 4 over negative 3 or just negative 4/3. And if that's bewildering, well, just remember, 4 divided by negative 3 is negative 1.3 repeating. What's negative 4 divided by 3? Also negative 1.3 repeating. What happens if I do a negative and then parentheses 4 over 3? Still negative 1.3 repeating. What happens if I say they're both negative? Well, you should probably use negative 4 over negative 3. In that case, we get a positive. So we always pay attention to how many negatives we get. If we get 2 negatives, it'll cancel out, we'll get a positive. But if it's just 1 negative on top or bottom, doesn't matter where, it's going to be the whole thing negative. So that's our slope, negative 4/3. Now we can find the slope of A prime, B prime. And on this one, I'll count the other way. Instead of going from the bottom to the top, I'll count from the top and go to the bottom. So on this one, we'll count the rise first. And in this one, it rises 1, 2, 3, 4, 5, 6, 7, 8. But it was 8 downward, so that's negative. And then from here, 1, 2, 3, 4, 5, 6. And that was positive. So 8 over 6, or negative 8/6. Those look like different numbers, but 8/6 simplifies. So just a reminder, anytime you have this, you can do math, press the math button, and press enter a couple of times, and it'll simplify it. I mean, or you can learn how to simplify these by hand. The way you simplify these by hand, we have 8 and 6. We say, is there something we can divide both of them by? They're both divisible by 2. So you divide them both by 2 and you get 4 and you get 3. So we got the same slope for the same side in our 2 different triangles. It was this side, all right. We're at AC and A prime, C prime. So AC, looks like we went up 4 again, but only over 1. So that would be negative 4 over 1. And then on this one, 8 and 2, and then the 2 is negative, so negative 8 over 2, and 8 over 2 simplify. Oh, I'm off screen again, sorry. You should really tell me when I'm off screen. You talk to a video and the person in the video is like, oh, thanks for telling me. Watch, that's where we'll be in 100 years. All right, so what do you notice? The slopes are the same. The slopes are the same because the angles are the same. So lines in pre-image are parallel to lines in image. Compare the angles in the pre-image to the angles in the image, make a conjecture. So I've already kind of said all this. The angles are preserved. The slope and the angle are inseparably linked. Let me do this. Maybe that'll help me stay in frame more. I moved my camera setup down. All right. Nothing but the highest quality videos on Mr. Campbell's YouTube channel. All right. Let's take a minute and look at our quick notes. So we're gonna get a nice little definition for what a dilation is. Then we'll do some practice. So dilations transform dilations are a type of transformation that enlarge or reduce a figure from the center of dilation by a scale factor. Pre-image times scale factor is equal to image every time. Angles and ratios, I wrote rations. Ratios of sides are preserved. Lines stay parallel. And then a little kind of side note, the center of dilation doesn't move, but everything else does. All right. So there's our quick notes. Let's see. Quadrilateral ABCD was dilated to produce this image A prime, B prime, C prime, D prime. Is the dilation an enlargement or a reduction? Let's see. Here's A, B, C, D. Here's A prime, B prime, C prime, D prime. So primes are the new one, the image, and the A, B, C, D is the pre-image. Well, this is littler, right? So it's a reduction. What is the center of the dilation? So this goes along with that last thing we wrote here. Was there any point here that didn't move? And it was D/D prime. So point D is the point, we should label it. It's 1, -4. Find the scale factor. All right, this one is a little tricky because I don't have just a flat one to go off of. If you remember on the previous page, we had a flat one and a flat one. It was super easy to count them. We're gonna have to do the Pythagorean theorem, and you can do any two sides you want that match up. So I could do AB and A prime B prime. I could do AD and A prime D prime. It doesn't matter. And since it doesn't matter, I do like the way this goes. 1, 1, boom, boom. Oh, it looks pretty easy. I like that one. So it's on a whim. I chose that one. I could have chosen any one. I looked up at the answer key after I picked this. That's the same one they picked. But you could pick anyone. You could pick this one over here, this one over here. It doesn't matter. Actually, this one would be tricky, wouldn't it? To go from B prime to C prime, because that's not quite on any, we call that a lattice point, right? It's not, this one's crossing at a lattice point, but this one's not crossing at a lattice point. It's not crossing exactly on the grid at whole numbers. Okay, so, well, for this one we got 3 and we got 3, so I can do, that's our hypotenuse then, right? So 3 squared plus 3 squared, that's 9 plus 9. That's the square root of 18. And I'm gonna do a little trick. I'm actually gonna leave this as the square root of 18. Let's see what this is. 1 and 1. So that's 1 squared plus 1 squared. So that's 2. So square root of 2. So can you tell how much bigger these are from each other? Don't be fooled. I want to say they're 9 times bigger than each other, but these are square roots of these numbers. So if I take the square root of 18, and then notice how I clicked out of that. You want to click out of that. Divided by the square root of 2 actually is only 3, because 3 is the square root of 9. So it's a square root of 9 is the difference. So 3 is our scale factor. Oh wait, no it isn't. Hold on. To find scale factor, we do new divided by old. And so this is where, like, if you say the scale factor is 3, you're saying if you go from this little one up to the big one. Technically speaking, we would talk about scale factors going from the big one down to the little one. And so we would need to do new divided by old And so we would need to do square root of 2 divided by square root of 18. And that's how we would get from big down to small. You can do the convert to fraction with math, enter. I got 1/3, which is the reciprocal of 3. So 1/3 is our actual scale factor. And it's a reduction, so that makes sense. It should be a smaller number. If the measure of B, angle B, is 98 degrees, what's the measure of B prime? This is really hard. It's probably going to take us the rest of the video to do. Just kidding, it's the same number. I don't know why I like that joke so much. It's not funny, but it's like my favorite joke as a teacher, when something's no work at all and then I act like it's work. Sketch the image of triangle ABC after a dilation from the origin by a factor of 2. All right. Here's how you do this. There's lots of ways to do it, but my favorite way, so about the origin, that means we start here. And if we're doing a factor of 2, then that means it's double, right? Whatever we did to get to one point, we're going to double that. So whatever we did to get to here, we're going to double that. So I went up 1 and over 1. So I'll just do that twice then. Up 1 over 1 and I'll up 1 over 1 again. That'll be A prime. So if I want to find C prime, and you can switch the order, doesn't matter. C prime I went over 4. So how much am I going to go over to get to C prime? Over 8. I think I said C prime twice. For C, we went over 4. For C prime, we're going to go over 8. And then for C prime, we went up 2. And for C prime, that means we'll go up 4. So over 8, up 4. There's our point. And then we can do the same thing. It's over 3 for B. So that means it's over 6 for B prime, because it's double. Up 4, well, that's going to be up 8. Also double. Another way to do it is if you look at this, the diagonal that it creates, you can kind of see the shape that diagonal makes, and then double that shape. Like just do it again. So we have this 12 block rectangle. You just add another 12 block rectangle on it, and you know it's going to be there. So and then I really don't want to draw crooked lines here, so I am going to use a ruler. There we are. So that's a dilation lesson. I mean, that's a lesson on dilations. Hope it was helpful. Bye.